Right then, lithium. It's a word you hear quite a bit these days, isn't it? Especially if you're into an electric car or a newfangled phone. But what actually is it? Well, it's an element, one of the basic building blocks of everything. You'll find it on the periodic table, that big colorful chart they have in science classrooms. It's got the symbol Li and it's number 3, so it's right near the start. This tells us it's a rather simple sort of atom, not too many bits and bobs making it up. It's also the lightest of all the solid elements, which is quite an interesting little fact to tuck away for a pub quiz perhaps. Now, being a metal, you might think of something hefty and strong like iron or steel. But lithium, well, it's a bit different. It's an alkali metal, which means it's part of a rather reactive family. It's so soft you could cut it with a butter knife, not that you'd want to, mind you. It's silvery white, but it doesn't stay that way for long if you leave it out in the air. It reacts with oxygen and water quite enthusiastically, so it has to be stored carefully, usually under oil or some other protective stuff. Not the sort of metal you'd make a teapot out of then, definitely not. You won't just stumble across a big lump of pure lithium while out for a walk, I'm afraid. Because it's so keen to react with things, it's always found combined with other elements and minerals. Think of things like spodumene or petalite, rather fancy names, those. These minerals are found in certain types of rock, often granites. Another place we get it from is brine, which is basically very salty water. This brine is pumped up from underground pools, particularly in places like South America, in those vast salt flats you see in pictures. It's quite a process to get the lithium out, as you can imagine. The chaps who first pinned it down as a unique element did so back in the early 1800s. A Swedish chemist named Johann August Arfvedson gets the credit for discovering it in 1817. He found it while looking at that petalite mineral I mentioned. They called it a lithium, from the Greek word lithos, which means stone, because it was found in a mineral. It took a bit longer before anyone managed to isolate the pure metal itself. It wasn't immediately obvious what it would be good for, but like many scientific discoveries, its true potential was just waiting to be unlocked by clever people later on. So, why all the fuss about this light reactive metal? Well, the main reason, the big one, is batteries. Specifically, lithium-ion batteries. These are the powerhouses behind so much of our modern kit. Your smartphone, that tablet you might be reading this on, your laptop, chances are they all have a lithium-ion battery inside. Lithium is brilliant for batteries because it's so light and it can store a lot of energy. It's also very good at letting go of its electrons, which is what electricity is all about, really. A flow of electrons. This makes for a battery that is both powerful and doesn't weigh your pocket down too much. Think about your mobile phone. It does all sorts of clever things. Calls, internet, maps, taking photos of your dinner. All of that needs power. And it needs to last for a decent amount of time. Older battery types, like nickel-cadmium ones, were much heavier and didn't hold as much charge for their size. Lithium-ion batteries changed all that. They allowed gadgets to become smaller, thinner, and last longer between charges. It's quite remarkable, really, how much we rely on these little power packs. Without lithium, our portable electronics would be a lot clunkier and probably a lot less useful for our busy lives. And then there are electric cars. This is where lithium is really making headlines. An electric car needs a very big battery, much bigger than the one in your phone. Lithium-ion technology has made these large batteries possible. They can store enough energy to drive a car for hundreds of miles, which is rather impressive. Because lithium is so light, the battery doesn't add too much weight to the car, which helps with efficiency. This shift to electric vehicles is a huge change, and lithium is right at the heart of it. It's helping us to move away from petrol and diesel, which is a good thing for the air in our cities, I reckon. It's not just phones and cars either. You'll find lithium batteries in all sorts of other things. Power tools, for instance. Cordless drills, saws, and garden trimmers are so much more convenient without a cable trailing behind them. Medical devices like pacemakers and portable defibrillators rely on dependable, long-lasting lithium batteries. Even some children's toys use them now. It just goes to show how this one element discovered in a rock has quietly become essential to so many aspects of our daily lives, providing that crucial spark that keeps things moving, quite literally in some cases. It's the invisible force making modern life tick. Now, while batteries are lithium's main claim to fame these days, it's a surprisingly versatile chap. It has some rather interesting uses in other areas too, some of which might surprise you. One of the most significant is in medicine. For many decades, lithium compounds, specifically lithium carbonate or lithium citrate, have been used as a mood stabilizer. It's prescribed by doctors to treat conditions like bipolar disorder, helping to even out the extreme highs and lows that people can experience. It's quite extraordinary when you think about it. A simple element having such a profound effect on the workings of the human brain. How it actually works in the brain is still something scientists are trying to fully understand. It's a bit complicated, as brains often are, but it seems to interact with various neurotransmitters and chemical pathways in the brain. These are the chemical messengers that help brain cells communicate with each other. By influencing these pathways, lithium can help to reduce the intensity of manic episodes and stabilize mood over the long term. It's not a cure, but for many people, it's a treatment that can make a huge difference to their quality of life, allowing them to manage their condition more effectively. Quite a responsible job for a little metal. Another rather high-flying application for lithium is in the aerospace industry. Remember how I said lithium is the lightest, solid element? Well, that's a very attractive property if you're trying to build something that needs to fly. Lithium is used to make special alloys, particularly lithium-aluminium alloys. Adding a bit of lithium to aluminium makes the resulting metal significantly lighter and stiffer than aluminium on its own. This is incredibly useful for building aeroplanes and spacecraft, where every kilogram of weight saved means less fuel is needed or more payload can be carried. It helps make air travel more efficient, which is no bad thing. And the list doesn't stop there. Oh no. Lithium also pops up in things like ceramics and glass. Adding lithium compounds can lower the melting point and viscosity of glass, making it easier to work with and also making it more resistant to thermal shock, less likely to crack if it heats up or cools down quickly. Think of your glass ceramic hobs on your cooker. Lithium is also used in high-temperature lubricants and greases because it helps them perform well over a wide range of temperatures. It's even been used in air purification systems, such as on submarines and spacecraft, to remove carbon dioxide. Quite the all-rounder, really. Now, all this wonderful lithium powering our lives has to come from somewhere. And this is where things get a little bit tricky, a bit of a muddle, you might say. Extracting lithium from the earth isn't always a clean business. The two main methods are hard rock mining, where lithium-bearing minerals are dug out of open pits, and brine extraction, where lithium-rich saltwater is pumped from underground and evaporated in huge ponds. Both of these can have a significant impact on the environment. Hard rock mining can scar the landscape and produce a lot of waste rock, which needs careful management. The brine extraction method, common in places like Chile and Argentina's Lithium Triangle, uses vast quantities of water in very arid regions. This can put a serious strain on local water resources, affecting farmers and indigenous communities who rely on that water for their livelihoods. There are also concerns about the chemicals used in processing and the potential for leakage from the evaporation ponds, which could contaminate soil and water. So, while lithium itself is helping us build greener technologies like electric cars, the way we get it can be less than green. It's a bit of a paradox, isn't it? A classic case of solving one problem while potentially creating another. This means we really need to be clever about how we go about things. There's a growing demand for more sustainable and responsible lithium mining practices. This includes developing new extraction technologies that use less water and energy and have a smaller environmental footprint. Companies are also under increasing pressure to ensure they are respecting local communities and ecosystems where they operate. It's about finding a balance, ensuring that our quest for a cleaner energy future doesn't come at too high a cost to the planet or its people. It requires a lot of thought and a fair bit of investment in doing things the right way, not just the cheapest way. And what about all those batteries once they're finished with? We can't just keep throwing them away. That would be an awful waste and create yet more environmental problems. Recycling lithium-ion batteries is therefore incredibly important. It's not straightforward as they contain a mix of valuable and sometimes hazardous materials. But good progress is being made in developing more efficient recycling processes. By recovering the lithium, cobalt, nickel, and other materials, we can reduce the need for new mining and create a more circular economy for batteries. Lithium is undeniably a wonder material, central to modern tech and a cleaner future, but we must be mindful. Its continued success depends on us using it and sourcing it wisely and sustainably for the long haul.